We're recording. All right, let's do it. So we still remember how to integrate like x to the power 4. That becomes x to the power 5 over 5 plus c. You've just got to stop me once I guess something gets a bit confusing. But something like this, that changes to x to the power of a half. We're trying to integrate that, so that becomes x to the power of 3 over 2 multiplied by 2 over 3 plus c. Do we understand why I got a 2 over 3 here?
Yeah, you multiply by the reciprocal.
Yeah, all right, done. Everyone's comfortable with that. Limit, we would have integrated normally and then just subbed in. So that gets me x to the power of 3 over 3, sorry, times 3. And then the 3's would cancel out. 2, 1, sub in 2, 2 cubed minus 1 cubed. 8 take away 1 gives me something like 7. Any issues with that one?
No.
So let's actually go and do what we did before, which is, so we've pretty much done the 2-unit integration that's required. Today we're starting with 3-unit integration. So 3-unit integration is called integration by substitution. That's a bit of a different technique than you might be used to, but I think we can do well with this. Well, a little bit easier for all of you to see. I might take a snapshot of this, and then we'll make a new page. We'll paste it right here. Let's do this. All right. So find the integral of x root 1 plus x squared using the substitution u equals 1 plus x squared. All right. So what we've got to do, the idea with this is we can't actually integrate a function that has an x multiplied by another x. So there's no product rule like we said. So now we've got to use different substitution to be able to reduce this to something that we can actually integrate. Oops. So what we're going to do, if I can just get rid of that, which I can't, what we're going to do is we're going to first start off with our substitution. So u equals 1 plus x squared. Does that make sense? Step 1. Step 2, we differentiate u. Now the derivative of u is technically 1, right? So if I was to differentiate u, we would write 1. Now, what I might have not spoken about before, and I probably haven't, we have a question and we've written y equals x squared. We differentiate y, we would write y dash equals 2x, right? Y dash can also be written as dy on dx. So y dash and dy on dx are the same thing. So you're allowed to write d of the left-hand side equals to over d of the letter of this, so d on dx. So let's do another one of this. If I said y equals x cubed, dy on dx becomes what?
3x.
So dy on dx just means y dash. Okay. Now what I am allowed to do, just using basic algebra, instead of having the dx on this side, I can also multiply it and have it on this side. Do you all agree with that?
Yeah.
Okay, and that's pretty much what we're going to do. So look at this side. I've written y becomes dy. Yep. Say it again. No, I think you're with Emily. Just talk to her. I think you're meant to be splitting it up. I'm not too sure. From what I understand, it's meant to be. If she doesn't have, see who's with her. If she doesn't need to split up, then maybe that is the only class right now. Dy equals 3x squared dx. Sorry, you guys. And then, wait, let's start again. feel like I'm jumping all over the place with this one. So if I had y equals x cubed, you can write dy on dx, right? For y dash. Now that becomes the root of x cubed is 3x squared. Instead of having the dx on this side, we're going to write the dx on the right-hand side. So it's going to look something like this every time we differentiate for integration by substitution. So let's have a look at that. The derivative of u becomes du. The derivative of the right-hand side becomes 2x dx. Do we get that?
Yeah.
Everybody, if I don't hear nothing, that means I'm assuming
Yes.
I just continue, right? All right.
Yeah, it makes sense.
So then what we're going to do now, you see this bit here that says x dx? That is x dx. But I've got an extra 2 here that doesn't exist here. So what I'm going to do is actually move this 2 over this side. So now when I'm trying to substitute, because the whole point of this is just simple substitution, x dx gets replaced for du on 2. X dx just got replaced for du on 2. Then that becomes the square root, all I'm left with is the square root of 1 plus x squared. 1 plus x squared is u, square root of u. Does that make sense? Let's go again. Let's have a look at that. Wait. Let's delete this. If I can. No, I can't. All right. Let's go again. Look at this. So x dx from this side got replaced, x dx gets replaced for du on 2. There it is. Then I'm left with a square root. There's my square root. And then inside is 1 plus x squared. And I just write that as u. Why do I write it as u? Because u equals 1 plus x. The whole point of substitution is to, I guess, you're eliminating all your x's and replacing them for a different letter. In this case, it's u. Now, if I rewrite that just a little bit nicer, that you can integrate because it's just u. What is the integral of u to the power of a half? U to the power of 3 over 2. You add 1, you divide it by the reciprocal of this. So that's 2 over 3, but you still have this 2 times 2. And then in this case, plus c, 2 and 2 cancels out. U to the power of 3 over 2 all over 3 plus c. And with any substitution, you always replace your substitution back in. So if u equals 1 plus x squared, that means your final answer is 1 plus x squared to the power of 3 over 2 all over 3 plus c. All right. Have we copied that down?
Yeah.
Integration. Yes, everybody?
Yes.
Next question? Or
Yeah.
not yet? Next question. All right. Let's look at the next one. It gets pretty easy, this one. I promise you. Just got to keep following the same technique. The substitution will always be given to you in 3 units. In 4 unit, it will not be given to you. You have to identify it yourself. All right, which we'll get to when we need to. So first line, u equals x squared, take away 4. Next line, we differentiate this. So what's the derivative of u? What would you write? The derivative of u?
du.
du. What's the derivative of
Right.
x squared?
2x.
2x, and then you have to write your dx as well. If you guys are struggling with why I'm writing the dx on this side, or why I'm even writing it like this, like I said, if I had this question before, u dash is the same as me writing du on dx, and then du on dx becomes 2x. But instead of having the x on this side, I want the x's on both sides. So that's technically what I'm doing there, all in the one line. All right, get rid of that. I don't need that. Yeah. Okay, just leave that there. Okay, okay, now we're trying to substitute, right? So square root of x squared minus 4 would literally become square root of u. Square root of x squared minus 4 becomes square root of u. Yes, we see that?
Yep.
We've got an extra 4x dx we need to replace, but I've only got a 2x dx.
Multiply
Obviously,
by
what are you
2.
going to do? Yeah, multiply by 2. So technically it's going to become 2 du, which equals to 4x dx. So now 4x and dx can get replaced for 2 du. We usually just write du at the end. I think you guys know that from all the integration questions you've seen. We usually write the d's at the end. And then that looks like a standard question again that you've been doing. Next line, you would write, constants can always be written in the outside because they don't affect you. So they can be written like this, u to the power of a half, du, next line, 2, big bracket, u to the power of 3 over 2, times 2 over 3, plus c. 4 over 3 plus c, and then what's the last line we've got to do? Last step.
Just put the substitution instead of u.
Substitution in u over 3 plus c. We ready for the next question?
Just 2 seconds.
Yep. Just reduce there. Nobody else is talking. Are you guys all getting it? I'm not sure.
Yeah.
I can see everybody else is on mute. But just making sure, please, you have to stop me if it's getting a bit confusing. All right, get back to you. Move on to another question.
Yep.
Yep. Let's try the next one. All right, you guys want to start this yourself, and then we'll see if you get the same u and du as me. So u is obviously given, that's easy. Let's just make sure we get the same du. All right, what's our answer for du?
3x squared dx.
Good job. 3x squared dx. And then again, it does say 6x squared dx. So of course, we're going to multiply this by 2. So the logic, if you're starting to get this, is we want this side to look exactly like what we're about to substitute in. Otherwise, it'll be very complicated. So if I write 2 du, that is 6x squared dx. So if I needed to substitute 6x squared dx for something, I now have it as 2 du. So my new integral becomes 2, and then I usually write du in the end, and then square root of 3 plus x cubed. Oops. 2. I usually write the 2 on the outside. Constants can be written in the outside. What was that again?
10 minutes.
Huh? With us?
Milan, we will have a compulsory meeting at 8:15 online tomorrow, okay? And
Okay. We're all good? 4/3. U is x. U 3 plus x cubed. 3 plus x cubed. 3/2 plus c. Any issues with that question? No? Everybody's fine?
Oh, good.
All good. All right. I feel like I'm going fast, but no one's saying anything. So you guys might be doing really well. I'm just going to keep moving forward. Yeah, we've done logs, so now we can answer this question. Copy to clipboard. And you'll get you'll get this whole document, like I said, and the recording to go over again. All right. So now we've got to integrate ln x on 2x. And you can obviously see straight away that this is not your stock standard question, right? It's a little bit different, and that's why we've got to use these substitution questions. So u equals to ln x. Du equals to, what is the derivative of log x? What is the derivative of log x? Anyone remember what we're meant to do?
1 on x.
Isn't the original
Derivative of the x is 1
the
over
okay, yeah.
the original is x, and then the x. Now, what do I have here that I don't have here? What do I have in the original question?
2x.
Yeah, the fact that it says 2x. All you do is divide this by 2, and now this will look exactly the same as what you want to sub it in. Into here, dx on 2x, dx on 2x. Next line, integral. What does ln x stand for? Just u times du on 2. Oh, that's a simple integral now. That just becomes u squared on 2 times 2, because there's a 2 still there, right? Plus c. U is what? U is ln x, so your answer is ln x 4 squared over 4 plus Any questions, you guys?
Okay.
No? All right, let's go. Question 5. Doing well. I might get you guys working on this by yourself first. If you've got no questions, then I'm just going to go ahead. Question 5, please. All I will do for you, I will start you off with your u and du. So u equals x cubed minus 1. Du becomes 3x squared dx. You don't want the 3 there. You only want x squared dx. So you've got to get rid of this and look, substitute them in. There you go. How are we going? What do we have? What do we have so far? Novak, have you done it yet?
No, not yet.
What line have you written? What's your next line after this?
I'm kind of lost, to be honest.
I've been saying that.
I know, I don't know.
Okay, let's do it. To anyone else that's lost, can we say it now, please, so I know?
Kind of.
Same.
Yeah.
No.
Lost for this question or lost with the whole technique overall?
Pretty sure for this,
This
question.
question.
This question, yeah.
This-
because the substitution's weird.
So, do we agree with my first two lines?
Yeah.
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 Next one. X squared dx gets replaced for du on 3.
Yeah.
du on 3. Are we happy with that?
Yeah.
Yeah.
No, that's
Yeah.
Yeah.
bottom now is the square root of what?
You.
Can't
Yeah.
be x cubed minus 1, so I'm going to replace it. Obviously, the top is just an imaginary 1, as usual.
Oh, okay. Yeah.
So, constants, if you really wanted to, you can take this 1 over 3 out. So it becomes 1 over 3. Integral du on root u. Are you allowed surds?
No.
No.
Next line. Let's just move it down here. No surds allowed. Third, are we allowed to have x's or u's in the denominator?
No.
No. You have to bring it up.
And now you just continue. 1 over 3, add 1, and then 2 over 1 plus c. Your final answer is 2 over 3. U was what? U was x cubed minus 1. So x cubed minus 1 to the power of a half plus c. All right, let's go through it slower now. Have a look at it. So from the top, all I did was x squared dx becomes du on 3. Then I decided to take 1/3 out. It became du on root u. Then square root of u, change that to u to the power of half. U to the power of a half becomes u to the power of negative half. And then integrate, and then substitute it back in. So now you can copy that down. Tell me which line.
Sam.
Yep.
For the one on the third, don't you have to multiply it?
1/3. Yeah, I did
Yeah.
multiply it. That's why it became 2 over 3 again.
Oh, okay. I didn't see the
Third.
2 over 3. Yeah, all good. Yeah, the bottom was blocking it. My bad.
Sorry. Yeah.
Gregory.
Shut up, mate.
All right. Let's go and do the next question. Question 6. You guys are seriously having no questions so far other than that. Like, that's amazing. All right. Let's go. This one. I won't say anything other than the fact that I'll give you u and du again. So u is equal to 3 minus x cubed. Du becomes negative 3x squared dx. Now I can see here I've got x squared dx. I don't want the negative 3. Voila. Simple fix. Now go and substitute it in. See if you can get that step out. If you want, tell me what you're going to write and I'll tell you if you're on the right track. What's your first line? Greg, what's your first line? What do you think? No, but no idea.
Du on
Yep.
3 times u to the power of 5.
Square
du
root of u, right?
negative
Oh wait,
3.
wait, Luke's
Negative 3. Yeah, negative 3. Yeah.
And it is u to the power of
5.
Five.
Yeah.
What are you allowed to do with this negative 3? Technically,
Uh,
just take it to the outside. 'Cause
Yeah, 1 on negative 3.
So it becomes negative a third. And then really just integrating u to the power of 5. Look how simple that is. What a simple question. For an extension 1 like question, that seems fairly straightforward. So it's just getting this step wrapped around your head, understanding how to substitute each of these letters, these x's, and then you're replacing them for u's. We'll finish it off. Negative a third, that becomes u6, u to the power of 6 over 6, plus c, negative u to the power of 6 on 18, plus c. U is 3 take away x cubed, so negative 3 take away x cubed to the power of 6 on 18 plus c. Are we understanding that?
Yeah.
Mm-hmm.
Do question 7. This time I'm not going to start you guys off. See how you go. So
Then could you go to the past question quickly?
go back.
Yeah, I'm just gonna finish it.
Sure.
Yeah, all good.
No problem. Anybody else? Or,
It's all good, Tim. I took a photo.
all right. Question 7. Like I said, you'll get a recording. Yeah, I don't think you need to take a photo, but it's up to you. Question 7. Stefan, you there? You're doing well with this?
Yeah, yeah.
Rosemary?
Yeah.
Yeah. Are you sure? 100%?
Yeah.
Okay.
Yeah.
This one's a little bit more complicated, only because once you differentiate the x, it's going to get you just 1 dx, but you still have an x here. So I'll see what you guys try to do with this. Maybe if we can, if you're writing it down on paper, you can just show it to me on Skype. I would like to see what your working out is.
Is it 6x du equals 6x dx?
You can't have x with u.
Oh, okay, so get
So
that.
somehow you
Oh,
can think of
okay.
a way
6
to get rid of
du.
x.
6x dx on x, something like that.
No, but you want to replace the x, right? For
Yeah.
you. So let me try it now. 1 second. I'll get. All right, let's have a look at this. Anybody else want to show me what they've got, or
I got the same thing as Greg.
so you got it with the x's, right?
Yeah.
Yeah, fair enough. So the idea, if we go back just quickly, so we can understand this. Look, the problem is we've got these x's, obviously in the original question, and what we must do is write an integral that does not contain any x's and only contains u. So you're not allowed to have two different variables in the one integral sign.
Yep.
So keeping that in mind, let's see how we're going to do this. So u equals x plus 5. Du becomes just 1 dx. So it just becomes dx. Yes?
Mm-hmm.
Everybody's all right with that?
Yep.
Yeah.
All right. The problem is, I mean, this dx becomes du. Easy. Done. This becomes u. Easy. And the problem is it's this guy. I've still got an extra 6x. Anybody have any idea? I mean, the 6 is not an issue because 6 is, remember, constants can just go on the outside for your integrals. But now we're left with an x. Anybody have any ideas of what I can do with that x?
Turn it into U.
Yeah, how? X equals?
1.
No.
Uh,
come on.
minus
When you
5.
differentiate.
Yes. You just said it. U minus 5. X is actually just another way of saying u minus 5. If you know u equals x plus 5, well, just subtract the 5. Now you've got x in terms of u.
Okay.
And then you have this expression. And what would you do when you have something like this? You're obviously going to expand, right? So next line, that becomes u to the power of 5 minus 5u to the power of 4 du. And then just integrate normally. U is x plus 5. Okay. What do we think? Are we stuck with any of these lines? First line, second line? Anybody have any issues with what I've done here? No?
I think the hardest part is just to get du.
Say that again?
The hardest part is probably to get like du.
Yeah, that is meant to be the hardest bit of it. But can you see how I get du? Because the derivative of u, derivative of any letter is just going to be 1. And then it's 1, because you differentiated u, we usually write du. And then derivative of x is also 1. And then that becomes dx. Then you replace your dx for du. You replace your x plus 5 for your u. And then the 6 went in the outside, and then it's just the x that was meant to be a little bit harder in this case. All right, let's so the next question.
Yeah.
Question 8. This one should be, yeah, should be exactly the same as question 7. I guess in difficulty. So what will happen is when you differentiate this side, you're only going to be left with 2, but you're still going to have an x. So you're going to make x a subject from here. So all I want you guys to do is just show me what your first line would be. Your integral substitutions of this line. I just want to see if you can get this first line out. There. That's at least du for you. Now you've got a 3 dx, which is useless. You just want like that. You'll replace it for dx. X becomes du into. All right. Let's try this. Azra, I'm going to pick on you. I'm sorry. You there?
Yep, I'm here.
Let's do this question together, please. So, integral dx gets replaced for what? This dx.
I'm not too sure with this one yet.
This dx will get replaced for right here. What do you think it is?
du on 2.
Beautiful. Okay, so that dx gets replaced with the u on 2. What about this 2x minus 5? It will get replaced for what?
You would u would
U.
put u in there.
Yep,
U to the power of 6.
U to the power of 6. The 3 can just go in the outside. And we're left with this x. What are you going to do?
I'm not too sure.
You're going to solve for x, aren't you? So the problem is I need to eliminate x, right? Ezra, I've got to get rid of this x. To be able to do that, I need to now go and find an equation from this line here, make x the subject, like I just did here. Now I've got x in terms of u. And what I'm able to do is actually replace this original x for u plus 5 all over 2. Does that make sense?
Yep.
Let's do that again, I think. The whole thing. We're going to start from scratch again. That's it. Just 1 second, you guys. Make sure we can add it to our class. How can I do that? There we go. Add. Are you there?
Yay.
Yep.
Yep.
Yep. Perfect. We're just doing integration by substitution. You'll probably be a little bit behind right now, but it's fine. I think you'll be able to catch up with this. So, not the best question to start with, but here we go. I'll just start from scratch, I think. Okay. Paste. All right. So let's look at that again. U equals 2x minus 5. We're going to differentiate u, that becomes 2u 2 dx. We only want dx, so we got rid of the 2. Then we're going to replace all of our, I guess, letters, right? So dx gets replaced for du on 2. 2x minus 5 gets replaced for u to the power of 6. 3 constants go on the outside, and then you're just left with this x. And that's when we said you have to add the 5, divide by 2. You got to pretty much make x a subject and sub it into here. And then let's move forward. So then we're going to expand this. That becomes u7 plus 5u6 all over 4. What am I allowed to do with the 4?
Take it out.
Take it out.
Well,
Yeah.
take it a quarter.
Yeah, take out a quarter, so just take, but you take it out, division of 4. And then integrate u7, that becomes u power of 8 over 8 plus 5u to the power of 7 over 7 plus c. And then last, we're going to substitute our u back in. as well as multiply this in. So it's going to look something like this. 3u over 32 plus 15u over 28 plus c. How are we with that? Was that all right, you guys?
Yeah, that one was alright.
All copied down. Can I do the next question?
Yeah, I guess.
Yes. Okay. All right. Exactly the same. So nothing new to learn. It's going to have limits now. So what's going to happen? Our limits need to change according to your x variable as well. So they've got to become u's, and then our final answer will not have any x's. It will actually be a number.
Yeah.
Look at that. Okay. Let's do this. So first line, you would write u equals 4 plus x squared. Next line, we write du equals the derivative of x squared 2x dx. Are we used to that by now? Novak, do you understand that as well yourself?
Yes, I do.
Yep, great. All right, so look, now we need x dx. So what are you going to do to this 2?
You're gonna divide it?
I'm going to divide it. So it's just going to become x dx, exactly what I can substitute.
Yeah.
And inside the square root, I've got 4 plus x squared, which obviously just becomes u.
You.
Oh, too easy. The only problem is now these zeros and ones. These zeros and ones are with respect to x. So what we've got to do is replace them and make them u's as well. So they're not hard. So you just write when x equals to 1, u equals 2. When x equals to 0, u equals. All right. Simple substitution back in like lower high school. Here we go. When x equals to 1, you're just going to get u equals 4 plus 1, 5. When x equals to 0, you get u equals 4 plus 0, 4. So our new limits are 5 and 4. We get that?
Yep.
So that becomes 5, 4. Let's have a look at it again. X dx gets replaced for du on 2. Du on 2. And then this becomes the square root of 4 plus x squared, which is, next line. What am I going to do with this over 2 here?
Take it out.
You know, you guys are starting to see it gets pretty repetitive, and that's how this should be. Don't forget, you're doing Year 12 Extension 1 Mathematics right now, and you're in Year 11, so it's amazing. Absolutely.
Yay.
Yeah. Half. Here we go. U to the power of 3 over 2 times 2 over 3. Now there is no more plus c. You will not write that, because you're not going to get a constant. You're actually going to get an answer with your limits, 5 and 4. So 2 and 2 will cancel out when you expand it. The answer will just become 5 to the power of 3 over 2 over 3 minus 4 to the power of 3 over 2 over 3. Do we remember that with limits? You substitute your 5, subtract, substitute your 4. I'm going to quickly get a calculator just to see if we can simplify this a little bit better. Okay. So my answer, let's have a 4 to the power of 3 over 2. It does simplify. So this becomes 8 over 3. 5, I don't think will simplify. Yep. So that we're just going to write in simplest form, which would be what? 5 root 5 on 3. And just to write it a little bit neater. There we go. Any issues with that question?
No.
Exactly the same. Let's just recap. We started off with u. We differentiated u. We got du. We realized you're going to have the 2x dx. We don't like that because we only meant to have an x dx. So we decided to divide by the 2. Then we changed our limits. When x is 1 and when x is 0, we found our new limits for u, which is 5 and 4, by simply substituting it into this expression here. And then we just integrated normally and simplified. All right. Next one. All right, you guys, go ahead and do that. All right. Let's do this. U equals 4 take away x squared. Du becomes negative 2x dx. Again, you can see we have a 3x dx, not a negative 2x dx. It might be a little bit annoying trying to get this negative 2 into a 3. So what I would recommend, instead of trying to do that, you would just divide by this, right? So you're only going to substitute for x dx, because remember this 3, I can just write it in the outside. So it won't affect us much anyways. And then x dx, yep, and then square root of 4 minus x squared. I have that for you. I think everything's ready. All we need to do is just get rid of our limits. X equals to 1, u equals to 3. When x equals to 0, u equals to 4. 3 in the outside, that becomes 3 and 4. X dx becomes du on negative 2. Write du at the end, put the negative 2 at the bottom, square root of u. Take the negative 2 out. Next line becomes, and then two and 2 will cancel out. 3 and 3 will cancel out. You're just left with negative 3. Well, I might use big brackets here. 3 to the power of 3 over 2 minus, you're subbing 4. 4 to the power of 3 over 2. Answer? is 8 minus cube root of, so 3 root 3. I just swap them around. That negative goes there, obviously, and that goes. All right. Everybody's all right with that?
Sam, can you scroll up a little bit, please?
Yes.
Thanks.
Anybody have any questions for that one?
No.
Oh, this one was alright.
This one's all right. All right, good. Squared at the bottom. The top will become that. Thank you. All right, let's try this one. Okay. I think this one first. All right, let's see. Let's go with this. That's your question to do now. All right. How did we go, you guys? We stuck? We have an answer, maybe?
Sam,
Yes.
after you get the U,
Yes.
you know how you swap everything from the X? Do you
Yeah.
start subbing in 2 and 1 then?
Pretty much, yeah.
Okay.
So it'll look like this, if that's what you're saying. U equals x plus 1. Du becomes dx only. And then you're saying...
And will the 2x at the
1?
top become 2?
Yeah,
So U2, U1.
that becomes 2 and 1, correct. So that becomes 2 and 1. This dx becomes du. That's done. This x plus 1 becomes u in the denominator. Done. This 2 can go on the outside. Done. The only problem is what?
It becomes U minus 1.
Yes, we've got this extra x here that we can't use. So you just go and simply make x a subject.
Yeah.
In terms of u minus 1. Now, what's the problem though? The fact that you've got a division of u here.
Yeah.
think Rosemary can help us out. Rosemary, what are we meant to do when we have it like this? Because you've done this one before. Over U. Any ideas?
Would you separate us, Sam?
Yeah. Rosemary, are you there? Hello.
Oh,
Interesting.
yeah, sorry. Sorry.
You
I'm
sure?
trying to think.
Yeah. Well,
Yeah.
this one here, you would split the denominator, right? Because that's what we said last time with those questions.
U on U minus 1 on U.
U on U minus 1 on U. Correct.
And then it becomes 1 minus 1 on U.
Yeah. And now, my turn. All right. So, 2, we're leaving the outside. Integral of 1. The integral of 1 is just U. The integral of 1 on U is log U, right, you guys? Because remember, when we had y equals ln x, we wrote y dash is 1 on x. Well, what does that mean if I integrated this? If I integrated 1 on x, what would it give me? Log x. So therefore, if I've got the integral of 1 on u, that becomes log u. And then the next answer is easy. 2 log minus log 2 minus 1 minus log 1. All right. And then big brackets there. That becomes 2 minus ln 2 minus 1. Log 1. Does anyone know or remember what log 1 equals to again? We'll just plug it into the calculator.
0.
0. And then 2 take away 1 is 1. So your final answer is 2 times 1, which is 2, minus 2 log 2. Follow up, you guys. The hardest step here, I guess, was the splitting the denominators firstly. No integral of 1 on u. Whoever it is that's got the news running in the background, if you don't mind, just move or
I think that may be me.
yeah,
I'll just mute. Yeah.
yeah, mute it or yeah. Done. Thank you. All right. Let's go with another question. I think we just did that one. This one should be exactly the same. All right, you guys, go again. All yours. Anybody need any help? Or should I start? I'll start. Someone's got to say something.
Yeah.
Okay, here we go. Let's do it. So, u equals 3x plus 1. du equals 3 dx. X equals 1, x equals 0. When x equals 1, you're going to get u equals 3 times 1, 3 plus 1, 4. U equals 3 times 0 is 0, plus 1 is 1. Okay, so our new limits are 4 and 1. This time we actually have 3 dx. So this 3 and this dx is going to get replaced for du. Our denominator is straightforward. It's 3x plus 1 squared, which means it'll just be u squared. That's gone. The only extra bit that I've got is this x. And that's when we have to make x a subject again from here. So x equals u minus 1 all over 3. So u minus 1 all over 3. And look at the way I do my fractions and everything, because I know a lot of students have problems with these fractions. They see I've only got a numerator and a denominator. Numerator and a denominator. I don't really split them up and write u minus 1 all over 3 in the one line. And like I didn't write for x, I didn't write it like this. That's just messy. It's a bit more complicated. So if it's in the numerator, I leave it in the numerator, and then I know that will go into the denominator. All right, and again, we're going to split it up. So that becomes, I'll take the 1 on 3 to the outside. It'll just be easier to deal with just the u's. So that'll look like this. Next line. Those two will cancel out. And then I'll let you guys finish from here. You'll need it to, that needs to be the power of -2 du. This becomes a log. This is just normal integration. So log normal. All right, let me see you guys finish it off. Anybody has an answer for this one? Yet or not yet? Anybody got these two lines out correctly?
Yeah.
Yeah. 1.
Yeah.
No, it's 2. Nobody else got this right? Stefan,
Yeah.
you did get it right.
Yeah.
Rosemary,
Yep.
yeah, Azra, you got it. You guys actually got this line.
Yeah.
Yeah.
And then all I've done here, two negatives here makes a positive, and then u to the power of -1 becomes 1 on u. So I just thought it's nicer. I personally prefer the fractions rather than the negative indices. And then all I'm going to do now, simple substitution, that becomes log 4 plus 1 on 4 minus log 1 plus 1 on 1. Log 1 is 0, so that just becomes 1/3. Log 4, a quarter, minus 1 is -3/4. And the final answer, of course, 3 on 3 cancels out. That just becomes a quarter.
Sam.
Yep.
Is it alright if you don't expand the 1 on 3, or do you always have to expand the 1 on 4?
No, you have to expand this. Yeah. Next question, or you guys are still copying down? Next, yes,
Still copying.
still copying.
I'm done.
Done. All right, thank you. I'll do this one yet because it's minus 10. All right, I think we're good. We've only got one more topic left and we are done with all of 3 units. So 3 units pretty short, as you can see, for integration. It's just substitution and integrating squares of sine and cosine. I don't feel fully confident with the substitution, so I think we might spend the rest of today doing substitution questions, and then we'll start squares of sine and cosine next week. So what I'm going to do, I'm going to first save this. Save as, we'll go desktop, Monday. Save. So I'll send you that copy so you guys can have your questions, and I'll send you this one as well. All right. So what am I going to do now? We're going to do exam questions, right? Once you start feeling comfortable with I guess, a question or with a concept, you jump straight to exams. All right, someone pick a year, whatever year they like.
2003.
2003. Thank you, Ben. Let's go with CWSA. First, let me have a look through it, make sure it's going to be applicable for us. No, it's just going to be annoying to try to turn that. Let's go with Barker. I don't want to do Roos yet. It opens up. What's happening? Good. Sydney Grammar. I mean, like, look how easy that is. Right, Sydney Grammar you're talking about. Look, what is the derivative of 5x squared? It's a joke of a question. That's too easy, so I'm just going to close that. Oh, that's why. We're in the wrong section. U12 extension 1. All right. 2003. That was advanced. 2003. All right, let's go again. CWSA paper trial. Scroll, scroll, scroll. Here. As long as the answer doesn't become an inverse. Question 5. No answers. X u minus 1 square root of u. No, you guys can't do that yet. That's not becoming inverse. Next. Try it again. Chromebook. Oh, the solutions I can just check quickly if it is inverse. So you see how I'm just jumping straight to exams? This is what you guys should be doing with your Year 11 papers. Straight. It doesn't become an inverse. Doesn't look like it. Alright, if it doesn't become an inverse, then we will do that question. Alright, let's look at this rather harder question for substitution because it is worth 4 marks. They're generally worth only 3 marks. So if it's worth 4 marks, I'm assuming it's a bit harder. Here it is. How do you know it's a, I guess, substitution integration? There's the integral sign and there's the word substitution. We'll specifically have to say that. In your exams. Okay, let's do this one. So it says evaluate this. Evaluate, remember, means find the value. So we must get a number. Using the substitution, u equals 1 plus square root of x. Okay. Now we're going to differentiate this, du. So what's the derivative of square root of x? How are we going to do that? What must you do with the square root first?
Make it x apart.
Okay, here we go. So the derivative of this is going to become half x negative half dx, which then becomes 1 on x negative half goes back down to x to the power of a half, which looks like this, which eventually becomes something like this. Do we agree with that? And that's actually pretty nice because we've got a root x in the bottom already and a dx on the top. The only thing I don't have here is this extra 2 that we've got. So I've got to get rid of this 2 by timesing this part by 2. Then I've got to change my limits. So x equals 1, 49, u equals, x equals 1, u equals. So when x equals 49, I get square root of 49, which is 7. 7 plus 1 is 8. When x equals to 1, 1 plus 1 is 2. So let's do this again. Let's have a look. Integral 1. 1 becomes 2. 49. 49 becomes 8. And if it's easier for you guys to keep crossing out every time you've used something, just do that for the time being. Dx on root x. Dx on root x. That becomes just 2. Put it in the outside. Du. Over square root of 1 plus root x, which is just u. How easy was that? And let's go finish this off. So again, you're not allowed to have 1 on root u in the bottom. That becomes u to the power of negative half. integrate u to the power of negative half becomes u to the power of positive half times by 2 over 1, 8 and 2, and the answer would be 4 root 8 minus root 2. I got the square root from the fact that it's a half. And then root 8 is 2 root 2 minus root 2, which is just root 2. So your answer should simplify to eventually 4 square root of 2. Four marks is massive. To be able to get 4% in something that is so repetitive, it's pretty good. So integration by substitution, fairly straightforward. Shall we do another question, or still copying down? Move on? Yes? Moving on. We'll close that. There'll only be one question, integration by substitution, in your exams. So don't expect too many. Page and page. Okay. Let's go another year. What year were most of you born? Was it 2004?
That's why I said 2003.
Oh, yeah. Okay. All right. Well, let's
Unless you're Greg.
look at a James Roos question. Okay, what year you want from James Roos now?
2005? 2005?
2005? All right. Good. So here, the #1 school in the state for the last, 20 years. Let's see if we're able to answer their question. Find acute. There it is. All right. 3 marks. Oops. James Roos. I feel confident as long as we know, or if we remember the integral of sine. I think we got this. And if we don't, we'll just recap that. That's very easy using SC. SC. Here we go. All right. That I think is pi squared on 16. For those who can't see it, it says pi squared on 16 and x equals 0 for our limits. All right. So first line, u equals square root of x, same as before. Same as before. Can't write it like that. We're going to have it like that, unless you're getting used to it and you already can see it, or visualize it, I guess. The answer this becomes is obviously half x negative half dx, which again becomes 1 on 2 root x dx. It's quite funny, I guess, that two different years, two different schools, CWSA and James Roos, had a very similar style of question. They deal with the square roots, and it's only because obviously square root questions are a lot harder to actually differentiate and integrate with. So more room for mistakes. Otherwise, the concepts are exactly the same. All right, look, again, there's no 2 here. I've got an extra 2. I've got to get rid of that 2. I multiply it over. Dx on root x. Dx on root x becomes 2 du. Done, done. I need to find the answer for when x equals 0. When x is 0, I get 0 to the power of a half, which obviously still is 0. And when x is pi squared on 16, square root that gets me pi on 4. And all I'm left with is obviously sine u. Sine u. Everybody okay with that? Ben, Greg, makes sense?
Yeah.
Yeah.
Yeah. And then all we've got to do, obviously, if you remember this action that I do, we're going up for integration. Integral of sine is negative cos. So is negative cos u, and then pi on 4 and 0. And then we've got to sub this in. Remember, pi on 4 is 45 degrees. So your answer becomes 2 negative cos 45 degrees minus negative cos 0. That minus is there because you're going pi before take away 0. Next one, cos 45 is negative root 2 over 2 using your exact values. And cos of 0 should be 1, if I'm not wrong. And then just expand and simplify that. Voila. 2 times 1 is 2. 2 and 2 would cancel out in this case, and you're just left with negative root 2. I think we've got time for one more. Let's do one more exam question. See how you guys don't need 1,000 textbook questions? You just need to complete your topic, understand the concepts, and then once you have done so, just start doing exam questions. Then you realize how easy exams really can be. All right. Second school in the States is Baulkham Hills. So let's go with that one. 2007.
Not anymore, sir.
Sorry? Yeah, exactly. Not anymore. I know. It's stuffed up. Yeah, here we go. Find Cartesian, simplify, solve, prove by mathematical induction. Oh, there you go. That's something you can do. Have a leading sum, hence or otherwise. Okay, not even in here, or did I miss it? Oh, there, right at the beginning. E. Looks so similar to the ones that we've already done. All right, last one. Let's go. So, u equals 2x plus 1. The derivative of u becomes du. 2x plus 1 becomes 2 dx. Again, compare it back to the original. I don't have a 2. I get rid of the 2. I divide by 2. I'm left with only dx. That's perfectly fine. So that means this dx now becomes du on 2. I usually write the half on the outside. There it is. 2x plus 1 becomes u. That becomes u to the power of 10. That's gone. Gone. I've just left with this x. Same problem as before. X equals u minus 1 all over 2. The 2 I usually put in the outside, like I keep saying. That becomes a quarter. U to the power of 11 minus u to the power of 10. And then plus c, because we don't have limits. Substitute your u back. Don't forget you must do that if you don't have limits. So this becomes 2x plus 1 to the power of 12 all over 48 minus 2x plus 1 to the power of 11 over 44 plus c. All right, you guys. I'm going to save this as the next one, Monday class 3. I'll probably send it today since we've been doing it here. I'll send it on to Skype. I'll send you the recording as well. Stop